Good afternoon, everybody, and welcome to another episode of Tech Tuesday. So today we're going to be talking about expanding on some of the things that we spoke about in the last session, last week, last Tuesday. So I'm not able to see your comments, unfortunately, when I'm planning to share my screen today. But let's jump in. So these talks are designed to be short, so that you can digest what's being discussed in kind of short bursts. And we're picking up and kind of developing on what we've spoken about in the past. So today we're going to continue to expand on the theme of why somebody would use the Sparkster decentralized cloud. So to kind of back things up, if you don't know much about Sparkster, Sparkster is a platform for decentralized computing, a decentralized cloud that aims to disrupt the traditional cloud computing industry, right? So that would be the likes of Amazon or Microsoft, and software developers that build software run their software in the cloud in environments that belong to, say, Microsoft or Amazon. And we're going to look at how decentralized technology can be used to fundamentally disrupt that industry. And my personal belief is, and the belief here is Sparkster, is that the future of cloud computing is decentralized. So let's dig in, and I'll explain why I think that's the case. So if we look at a traditional data center, and what you're looking at is a picture of a data center. It's full of a lot of expensive hardware. It's full of equipment such as air conditioning units, expensive air conditioning units, things like diesel generators and backup power and all these sorts of things. But if we were to construct a data center that consisted of devices that belong to you, like your mobile phone or your desktop computer, rather than expensive hardware like this, and if we were to able to do that over a decentralized network, what would that mean to the traditional cloud computing industry? What would that mean for the cost of running software in an environment like this? So let's take a look at that. So one of the things that's made cloud computing so successful is its reliable costs. And what that really means is that if we add servers and we look at, for example, the price of running a server, what cloud computing means is that as you scale your business, meaning that you need to run your software on more servers, you have a stable cost or a uniform cost in which you can increase or scale out your business, right? And if we analyze some of this, what goes into building this, whatever this arbitrary amount is per server, what goes into this? Well, the majority of this is costs. This part here is cost, and a portion of this is profit. And these are the profits that are earned by, say, Microsoft, or earned by Amazon or whoever, AWS or Microsoft Azure. But these costs, they're specifically the things that we just mentioned over here, which is the expensive hardware, the racks, the air conditioning, the diesel generators, massive buildings. This is costs that's difficult to avoid in a centralized environment. What decentralized computing aims to do is it aims to eliminate or reduce a significant amount of this cost. So we end up with being able to deliver decentralized cloud computing at a much, much lower cost. And really, the premise of what Sparkster is all about is that as we add more people to the network, we're able to bring that cost down, right? So servers is analogous for transactions, right? Why it's analogous for transactions is because a server, let's say a server can perform 1,000 transactions. So you could say that one server represents 1,000 transactions. So you have a stepwise function in terms of cost for every 1,000 transactions, but on a per group of 1,000 transaction basis, the cost is uniform, right? Whereas if you look at decentralized cloud computing, the blue line here, the way that Sparkster is designed is as more people join the network, we're able to process more transactions. And how we're able to bring the cost down is because the cost of renting your device is in your hands. You make the decision of how much to charge for the use of your device. So as more people join the network, there's more competition, and that competition results in prices being driven down, which means that we are not only able to eliminate cost, but over time, or eliminate a significant portion of the cost, but over time, because there's no real cost other than electricity for delivering or making your device available to the network, you don't have really infrastructure costs. You can compete with one another and reduce the cost to a price point that a company like Amazon or AWS could never compete with, right? And so what I'm really saying is that decentralized cloud computing could be delivered at a cost that's disruptive to traditional cloud computing, at a price point that they'd never be able to compete with unless they adopted such a model. And that's why this is an industry that will be disrupted by decentralized cloud computing. Now, why are we the company that will make that happen? Why is Sparkster the company that's going to make this a reality? Well, to answer that question, we need to dig into what's needed for a company to, what's needed in terms of the things that a decentralized environment needs to deliver if it is going to deliver on the premise of disrupting cloud computing. Well, the very first thing we need is high TPS, right? And Sparkster has amongst the highest industry claims. We claim to be able to deliver unlimited TPS, but practically speaking, 10 million transactions a second. And we've actually demonstrated publicly live on our YouTube channel 52,000 transactions a second. And I think we're amongst the highest demonstrable claims in the industry. So why do we need high TPS? Well, think about this environment. If you're going to take all the transactions, all the software transactions that are running on all of these servers, right, and move it to a single environment, which is decentralized, then extremely high levels of parallel transactions is really what's needed if you're going to be able to actually cope with demand. Otherwise, people will leave you because you'll end up disappointing them. The second thing we need is we need low latency. And what low latency means is that, I'm sure you've experienced maybe some other networks when you try and make a payment or you try and transfer tokens from one place to another place. It takes a long time for that transaction to occur. Sometimes it can be 30 seconds, sometimes it can be minutes, sometimes it can be hours. Being able to have extremely low latency, less than 1 second, is critical to being able to run business applications, right? In fact, in centralized environments, these transactions are being executed in significantly less than 1 second. So being able to deliver an architecture that enables you to have extremely low latency is critical. And some of our weekly tech talk, the weekly articles that you get from our tech team are going to discuss how Sparkster is delivering on low latency. And the third thing that's really important is if we're going to have adoption of this environment, people need to be able to build applications for this environment, right? And specifically, they need to be able to build applications easily. So we need what's called architectural transparency. Now, what architectural transparency means is that you don't need to understand the architecture of blockchain environments. So if you had to understand, well, how does Sparkster's consensus protocol work? How do we talk to the storage tier, and what's the communication mechanism? If you had to program all of that into your software, then it would be very difficult for people to build software for your environment. There'd be a big learning curve, right? So how Sparkster overcomes architectural transparency is that if you're coding for the Sparkster decentralized cloud, you're just building software in the same way that you know how to build software today. But as many of you may know, we also provide an environment for building applications without writing any code, in plain English. And this environment for building applications without writing any code is 100 times faster than traditional software development. So we not only provide architectural transparency, but we substantially reduce the adoption hurdles or the barriers to adoption by enabling anybody and everybody to build applications for the Sparkster decentralized cloud. So that's really all we're going to discuss today in this particular topic, in this particular session. Next week, we're going to delve into another area of what we kind of touched on last week. So I also want to leave you with some kind of updates on where we are and what's going on. So let me attempt to switch back. So I want to leave you with, hopefully you saw my screen there. I don't know if you did through the course of the presentation, but hopefully you did. What I want to leave you with is kind of the development updates that we have. So one of the things that we've achieved this week is that we've come up with a theoretical way where we might be able to substantially increase the number of transactions per second that we're seeing inside of our blockchain. So for those of you who've seen some of our previous videos, you'll know that we're able to achieve 1,000 transactions a second per cell. A cell is a blockchain, and how we achieve high TPS is we're able to have multiple cells that don't interact with each other. And because they don't interact with each other, we can talk to them in parallel, and that's how we achieve a network-wide, extremely high TPS. But within each cell, up to this point, we've been limited or bound to 1,000 transactions a second. Well, now we're able to achieve, potentially able to achieve significantly higher than 1,000 transactions a second. At this point, it's still theory, and we've got to build it and test it before we can put it into practice. And naturally, that will take some time. But the good news is that, that's a meaningful breakthrough for us. So there'll be more coming out about this. Do take a look at the article that we put out this morning. That's a summary of kind of what we achieved last week. And I look forward to seeing everybody in the AMA at the end of this week. Thank you all for your time. I'll see you soon in the Telegram group. Thank you. Bye-bye.